The journey begins with cacao trees, grown in warm, humid regions, where heat, rainfall, and shade shape every harvest. Cacao pods grow directly from the trunks and branches, hiding rows of beans inside a sweet white pulp. Most cocoa is produced by small farms, where harvesting still depends heavily on skilled hands and careful timing. When the pods turn ripe, workers cut them from the trees without damaging the delicate flowers nearby. Each pod contains dozens of cocoa beans, but at this stage they do not taste like chocolate yet. Fresh cocoa beans are pale, moist, bitter, and surrounded by fruit pulp that begins the first transformation. Fermentation is where the hidden chocolate flavor starts to develop long before the beans reach any factory. Beans are placed in boxes or heaps covered with leaves and left as natural heat builds inside. During fermentation, the pulp breaks down, temperature rises, and chemical changes begin forming the future aroma of chocolate. After fermentation, the beans are spread under the sun or dried mechanically until moisture falls to safer levels. Drying is critical because too much moisture can create mold, spoilage, and unstable flavor during storage. Once dried, the beans become darker, lighter in weight, and strong enough to travel across the global supply chain. From tropical farms to industrial plants, cocoa beans carry the foundation of every chocolate bar. By the time they leave the growing region, the beans have already passed through one of the most important flavor stages. Dried cocoa beans are packed into sacks, loaded onto trucks, and moved from farms toward warehouses and export centers. At collection points, the beans are weighed, recorded, and checked before entering larger commercial supply chains. Magnets remove metal fragments that could damage grinders, contaminate product, or create serious production problems. Optical sorters may scan the flow, identifying discolored beans, foreign objects, and pieces that do not belong. In some factories, workers still inspect beans manually, removing defects that machines might miss. This step is critical because one poor batch can influence the flavor of thousands of finished bars. Cleaned beans move through elevators and conveyors toward the roasting area, where transformation becomes more dramatic. Once cleaned and sorted, the cocoa is ready to face heat, pressure, and mechanical force. Roasting is one of the most important stages in chocolate manufacturing, turning raw cocoa into a richer aromatic material. The beans enter large rotating roasters, where controlled heat develops flavor and reduces unwanted moisture. Roasting temperatures and times vary because each cocoa origin reacts differently under heat. Too little roasting leaves harsh notes behind, while too much heat can burn the delicate chocolate aroma. As the beans roast, their shells become brittle and the inner nibs become easier to separate. After roasting, the beans are cooled quickly to stop the heat from continuing the reaction. From here, the roasted cocoa enters a winnowing machine that cracks the shells open. The cracked mixture is blasted with air, separating light shell fragments from heavier cocoa nibs. The nibs are the valuable center of the bean, carrying cocoa solids, cocoa butter, and intense flavor. Shells are removed because they can create rough texture, weak flavor, and unwanted contamination in chocolate. Heavy grinders crush the nibs, releasing cocoa butter and turning the dry fragments into a thick, dark paste. This paste is called cocoa liquor, although it contains no alcohol and is made only from ground cocoa. Cocoa liquor is the foundation of chocolate, carrying both the deep cocoa taste and the natural fat structure. For dark chocolate, cocoa liquor may be blended with sugar, cocoa butter, and sometimes vanilla or emulsifier. For milk chocolate, milk powder joins the mixture, adding creaminess, sweetness, and a lighter color. At first, the mixture is coarse, heavy, and gritty, far from the smooth chocolate people expect. To change that texture, the chocolate mass passes through refining rollers under controlled pressure. These rollers crush sugar, cocoa, and milk particles until they become extremely fine and evenly distributed. Refining is critical because the human tongue can detect rough particles that make chocolate feel sandy. After refining, the chocolate may look like dry flakes, but its texture has already been transformed. The refined material enters conching machines, where heat, motion, and time develop smoothness and flavor. Before chocolate can become a bar, it must be tempered, one of the most precise stages. Tempering carefully controls temperature to form stable cocoa butter crystals inside the chocolate. Without proper tempering, chocolate can turn dull, soft, streaky, or covered with pale fat bloom. Tempered chocolate flows with a glossy surface, a clean snap, and a structure strong enough for packaging. Now the transformation is nearly complete. The liquid chocolate is ready to become recognizable bars. Another layer of chocolate may cover the filling, sealing the structure before the bar enters cooling. The filled molds travel into long cooling tunnels where temperature and airflow solidify the chocolate gradually. Cooling must be controlled carefully because sudden temperature changes can crack bars or damage the glossy finish. Inside the tunnel, liquid chocolate becomes firm, shiny, and strong enough to release from the mold. At the demolding station, the molds turn over and finished bars drop onto moving conveyors. High-speed cameras scan the bars, detecting cracks, missing corners, bubbles, stains, or uneven molding. Checkweighers measure each bar as it passes, removing pieces that are too light or too heavy. Metal detectors protect the line by identifying tiny foreign fragments before the chocolate reaches consumers. Some samples are taken to laboratories where technicians test texture, melt behavior, flavor, and appearance. Temperature history is also monitored because poor handling can damage chocolate even after perfect production. Rejected bars are removed from the main line and may be reworked when food safety rules allow it. Printers add batch codes, dates, and traceability information, connecting every package back to its production run. Wrapped bars are grouped into cartons, counted automatically, and prepared for larger transport cases. Robotic arms or automated stackers arrange cartons onto pallets in stable patterns for warehouse handling. Finished pallets move into storage areas, where temperature control helps preserve flavor, snap, and surface quality. From the factory, chocolate bars travel to supermarkets, cafes, vending machines, hotels, and homes around the world. The result is a product that feels simple, but depends on farming, fermentation, science, and industrial precision. Every finished bar carries the story of heat, pressure, time, machinery, and thousands of carefully measured decisions. By the end of the process, bitter cocoa beans have become one of the world's most recognizable foods,